Hi, my name is Christoph Olscher. I'm from BOKU University. I'm a PhD student there, and I'm part of the REPOXYBLE EU project. BOKU University has a team of 2 members, myself and my supervisor Florian Pratt, and we are tasked in REPOXYBLE with developing the recycling system or recycling process for the newly developed Depolymerizable Closed Loop Epoxy resin systems, and also to give our input on matters of safe and sustainable by design with other project partners like Geiker and Temasol. The current epoxy resin systems or composite systems are not designed for recyclability. So their end of life is mostly thermal utilization or landfilling. A lot of resources get lost that way, high value fibers and other adjuvants. The novelty that our product will bring to the market is that we have included the recyclability already in the design phase, and in best case we'll be able to recover 85% or more of the inherent materials of the composite system, including the epoxy resin matrix in the form of building blocks. The main advantages or pros of the recyclable composites will be that we are able to use every material that we have put into the composite and use them in the same way that they were designed to be, not downcycle them or thermally use them for incineration. Also, they don't end up in the landfill. Additionally, this will add new market opportunities for the stakeholders that come in contact with these materials. The drawbacks or cons for the recyclable composites are that it's a new system that needs to be implemented from the view of the recycler. So if we have a new recycling system, we also need a new sorting system. We also need new collection systems. This is in the industry today a large problem because nobody likes change. Everybody wants to use the system they are used to because change requires resources, monetary resources and timely resources. The future application of recyclable composites is, in my opinion, almost limitless, because everywhere where we are using conventional composites, there's the opportunity to implement recyclable composites. The main challenge will be to fulfill all technical requirements in all sectors. One example for a sector would be the aerospace industry, where we have a stringent technical requirement regarding thermal stability, and where especially recyclable composites are still not at the level that they can hold a cup of tea to titanium, for example. In our laboratory, we are nowadays developing the complete recycling process for the systems that have been developed. This includes optimization of the depolymerization process, which is the main part within a depolymerizable epoxy resin system. And this will allow us to recover all other adjuvants that have been encased in the matrix, such as fibers, which are a high-value component within the aerospace and the automotive industries, but also nanoparticles, for example, from our project partner, that have been developed for thermal regulation within the epoxy resin matrix. The method we're trying to apply is based on chemical solvolysis, and using ambient temperatures and low energy costs. The recycling process is will be adaptable to other systems, at least in part. So there is a chance for other companies or other stakeholders to apply the process after, for example, we have patented it. As a university, we are right now planning to patent the developed recycling process, of course in cooperation with the project partners from the REPOXYBLE project. The highest goal that we want to achieve is another cooperations, hopefully with the same project partners, to increase the TRL of the recycling system. So after the project, we also will have to look for funding, and in this case we want to focus on producing and researching a suitable collection and sorting system for recyclable composites.